Decision tree. This section is to introduce a tree model, decision tree. Decision tree is a tree model for classification or regression since it is in the form of a tree structure after training the model. It allows to predict the value of a target variable by following the decisions in the tree from the roots down to the leaf node. A decision tree consists of branching conditions where the value of a predictor is compared to a training weight. During the training process, it is to determine the number of branches and the value of weights. However, decision trees are prone to overfitting. With pruning techniques, the decision tree can be simplified to overcome the overfitting. Here is an example on how to use decision tree to decide whether or not to offer someone a loan based on features such as income, criminal records, years in present job, and payment for credit card. With these features, we can build a tree and make decision on offering loan. For example, if the applicant's income is greater than $70,000 per year and has criminal records, he or she will not get the loan. Decision tree generates the output as a tree-like structure. This tree is built top-down from a root node like age less than 30 by breaking down the dataset into smaller and smaller subsets. Thus, a decision tree is incrementally developed by adding nodes including decision nodes and leaf nodes, where a decision node has 2 or more branches and the leaf node represents a classification or decision. The topmost decision node in a tree is the best predictor, called root node. The strategy to build a decision tree is a recursive divide and conquer from top to down. First step is to select attributes for root node and create a branch for each possible attribute value of the root node. Then the second step is to split the dataset into subsets based on these branches, where one subset is for each branch. Each non-leaf node of the tree contains a split point that is a test on one or more attributes and determines how the data is partitioned. Finally, repeat recursively for each branch with first and second steps until each partition consists entirely or dominantly of examples from one class. So the tree is built by recursively partitioning the data. This figure shows how the decision tree splits the data space with 2 features, weight and height. Therefore, the whole process of building a decision tree is to select features to split data to generate nodes. Generally, splitting cost should be minimum in this process. Entropy is a concept used in physics, mathematics, computer science, and other fields of science, which is a measure of disorder or uncertainty. Information entropy is employed to evaluate the splitting cost by averaging the amount of information involved in an event. It is defined as the negative logarithm of the probability mass function for each possible data value. P base I is the probability of getting the ith value when randomly selecting one from the set. In other words, there are n classes and Pi is the probability an object from the ith class appearing. Information gain is defined based on information entropy. It increases with the average purity of the subsets, which helps us choose attributes that gives greatest information gain based on the reduction of entropy. To build a decision tree, it is all about iteratively finding attributes that return the highest information gain until we achieve the leaf of the decision tree, which is to build branches of this tree in the fastest path and reduce the entropy in the highest speed. The procedure of finding this decision tree is in an up-down manner from the roots, which is to partition the data into subsets that contain instances with similar values. The definition of information gain is shown as the equation on the slide. Here is an example to show how to choose root node for building a decision tree.
We have three attributes or features including cross size, shape and filling size, and one target class. The first step is to select the root node based on information gain. We will calculate information gain on all three attributes, compare them, and choose the attribute with the largest information gain as the root node. On the right side of the slide, it shows how to calculate class entropy and the entropies of the subsets defined by the values of the attribute shape. We can use the same calculation to obtain the entropies of the subsets defined by the values of the attributes cross size and filling size. Finally, we can obtain the information gain of three attributes: cross size, shape, and filling size. Through comparing the information gain, we found the attribute shape is with the largest value, 0.454, so the attribute shape is chosen as the root node for this decision tree. Once we obtain the root node, other node selection will follow the same procedure to build the decision tree.
Thank you.